DDP is a different way to do data parallel training from Horovod. One of the motivations for DDP versus Horovod comes about when you think about how the computation and communication are overlapping when you're doing data parallel training. So if you do a data parallel training with TensorFlow, your graph gets compiled, and the communication steps actually can get overlapped automatically by Horovod when it's doing the backwards propagation path. So your model will go forward on every rank, and then as it starts to compute gradients moving backwards for each layer of weights, once it's done with a layer and it no longer needs that in the communication, in the computation pattern, which is typically at the very end of your network closest to the final loss score, it can start communicating that. And TensorFlow does this because it does a graph compilation layer, and it's not really imperative. A PyTorch, on the other hand, is imperative. So every step is executed sequentially by Python. There's no compilation in PyTorch by default. And so when you run Horovod with PyTorch, particularly at large scales and with big models, it will wait for the entire model to do the backwards propagation on each node and then start communicating. So you'll start to get poor scaling efficiency at large nodes. And DDP, it's a PyTorch package. It's built into PyTorch itself that actually, instead of wrapping your optimizer so that it waits until the gradients are all computed to do the communication, it wraps your model. So it knows as it's backwards propagating through a model, once a layer is done, it can start communicating across all the different nodes, and it will start doing that for you, and you get much better scaling efficiency. I've scaled this out to a quite large scale on Summit, up to 1,500 GPUs, and Horovod had a scaling efficiency for a big model of about 60%, and DDP was at 97%. So if you're using PyTorch at large scales, DDP is shown to be much more performant at scaling. In this GitHub page that I'm showing on my screen and that I've pasted in Slack, you can click on the link for their tutorial, which I highlight here, and they have a paper with the technical details as well. I'm going to take you through sort of the hands-on version of this. So DDP support uses collective communication libraries. Horovod does this too, but this means something like nickel NCCL on GPUs, and if you're doing CPU communication, it uses this glue library. This NCCL on Theta GPU means that all of the communication is actually GPU to GPU direct, so you get great performance there. Starting up DDP, though, is more complicated than Horovod. Whereas in the previous examples, you just needed to do a horovod.init, DDP is more complicated. It's compatible with MPI, but it's not using MPI directly. So to set up the environment, I do something like this, and you'll find this in both of the examples as well. You need to pass it with the method I use, which is an environmental script, environmental variables. It needs to know for each node what rank it is, what world size it is, and what's a master address and a master port. And I use this variable on Theta GPU CUDA visible devices to specify which GPU I'm using. So to get the rank, that just comes from MPI, and I can use MPI for Pi for that. Similarly, the world size comes from MPI for Pi. The local rank, which I use to set the visible devices, I extract from this MPI variable. So when you launch this with OpenMPI on Theta GPU, this variable will be set for each rank, and you can use this to get your local rank. Finally, for the master address and the master port, which is how DDP is communicating sort of which node is in charge, and it uses this to tell all the nodes about each other. I set the master address to whatever is rank 0. So I get its host name on rank 0, and I broadcast that to all of the other workers. And then the master port can be any open port. I just use 2345. You can change it to whatever you like. There are other init methods. So there's a one where you can pass each rank a globally available file, and they will all write a little bit to the file to tell each other about it. And I think there's another method where they can communicate directly with TCP. And you can learn more about these in the documentation above. To wrap your model in DDP, it's super easy. It's one line. You say model equals DDP model. When you do this constructor, it will automatically synchronize your weights at startup, and during training, all of the gradients get reduced automatically. DDP does all of this for you. So once you've done this somewhat more complicated setup than Horvath, DDP is really kind of a one-liner. I have two examples here. There's the MNIST and CIFAR10 examples. They're almost identical to the Horvath examples, but I swapped out all of the Horvath changes and replaced it with DDP changes. Feel free to do a diff and see what's different between these two scripts to compare Horvath and DDP. One thing you should know before you go and launch these these scripts is that they run in a container. So the previous examples used some Conda environments. These are using the NVIDIA Docker containers that NVIDIA distributes. DDP is pretty new, and the NCCL support and PyTorch are a little bit more unstable. So the NVIDIA containers are the most reliable way to run these. I'll walk you through how to actually launch a script that's running in a container on each node. But the general gist is that each Cobalt script will run, it runs on one node when you launch it, and then MPI run will launch n processes on however many nodes you want. And with 8 GPUs per node, we usually do 8 per node. And then if you have one node or two nodes, it'll be 8 or 16 total processes. Each process launches a Singularity instance. Singularity is a containerization software similar to Docker. This is what we support on our system. So I convert NVIDIA's Docker images to Singularity containers, and they're all available publicly on our software installation area. And if you look at the submission script, you can see where they are. Once each, go ahead.
Corey, can I pause you just for a minute? I want to point out people on Theta GPU should only be using one node. I see 2 users with 4 nodes. You do not need 16 GPUs to run MNIST, I'm sorry. And maybe there's some confusion that you're on Theta GPU versus Theta. If you are on Theta GPU, please only use one node. You only need 8 GPUs for any of these models. So can I ask the user, the last name Tamilo, please cancel your job with a QDEL and the job ID. And also Sala, please cancel your job of 4 nodes using the QDEL command, QDEL, and then the job ID. Thanks. Sorry.
Okay, thanks, Taylor. Where was I? Right, so I was talking about containers. When you launch your job, MPI run launches one Singularity instance per rank, and then each Singularity instance will run a script. So this is kind of a 2-layer execution instead of just one qsub command. And I'll walk you through this now. So if I come up here and I go to submissions, Theta GPU, I'll take a look at qsub pytorch cifar10.sh. This is the qsub script. What I do is I point towards a container, and you should all be able to see this, and I point towards a script. This is one in my home area. You'll need to change this to wherever you've cloned the SDL AI workshop repository. But once you change that, you should be able to set your script instead. And then I just do some calculations of how many total ranks. You can change ranks per node to change how many GPUs you're using at once to check scaling performance. I recommend you set this to 8. And then this just computes the total number of ranks. And then here's the MPI run call. And it does the total number of ranks. This host file is from Cobalt. It tells you what nodes that you were actually given. Typically, you'll only have one, and this will be a one-liner file. If you have a bigger job, which you shouldn't right now, but maybe there'll be opportunity for that later, it will read this host file, and it will start mapping nodes, mapping ranks by node. So it'll put the first rank on one node, the second rank on another node, etc. And then this is what I actually execute for this job. It calls Singularity, that's the executable. And then Singularity has some arguments. I tell it to run a script. --nv tells Singularity that we're looking for NVIDIA container support, so it'll have the GPU runtimes. -b tells Singularity that I need this folder /lus, which is our Lustre area, mapped inside of the container, so it will appear in the container. It doesn't do that by default. And then I give it the path to the container and the path to the script, and it runs. I'll walk through this script, and then I'll stop talking and field questions. So inside the script, it's pretty short. It enters the container and it sets up a virtual environment. I do this because the Python that comes in the container doesn't have MPI for Pi. So I've installed a compatible MPI for Pi in this virtual env, which is needed for the setup. In principle, you could do a different DDP setup that doesn't rely on MPI for Pi, and you wouldn't need this step, but I thought this was conceptually simpler. And then I CD to my directory where I've got the script. You'll obviously need to change this as well or it won't run. And then I run Python, PyTorch. I set the device to GPU and I run for 32 epochs. And note that there's no MPI run on this line. It's already running this command on every rank, and DDP will launch MPI for Pi inside of every script, and they'll all communicate with each other and know this. So there's no need for an MPI run in here. If you're on an interactive node, you can do this in a little bit of a different order. You can do an interactive session in Singularity and then do an MPI run on a single node from within your Singularity container. And if you have questions about trying that, you can ask me directly on Slack. Okay, the last thing I'll show is performance with DDP. So I took some numbers here on, this is one node using 1, 4, or 8 GPUs. How long did it take per epoch for CIFR 10 and MNIST? And you'll see that both of them are about the same. And then I went from 1 to 2 to 4 nodes with 8 GPUs per node, and I measured the time per epoch. And you can see the scaling performance is not quite linear, and that's because even though it's overlapping communication and computation, these models are just so small that it finishes the back propagation step before it can possibly finish all the communication. So if you had a bigger model, you would see better scaling performance, even up to a large number of GPUs. Okay, I'll stop lecturing. I'm happy to field questions here live and send them on chat as well. If there's no questions, I can add one more comment. In all of my Q subscripts, I've set the time to be 10 minutes, which is more than enough time to run even one GPU on one node to finish the scripts. So if you're launching these directly, there's no need to change this to more than 10 minutes. And I set pubnet equals true so you can download the data directly.
That's a good point, which I think Corey pointed out in Slack as well, that if you include on theta, so on theta GPU, if you want to get outbound communication, you can add this command line, or command to the Cobalt, the Q sub command, the -- attributes equals pubnet. We are still answering questions on, so Filippo asked if we can run DDP on theta. I think that's a yes.
It should be a yes. Let me make a comment about that. Because PyTorch is imperative and it comes back into Python for each execution, when you're doing your model computation and your backwards propagation, PyTorch is very slow on theta because theta is a CPU and it does all the computations there, and then it has slow Python performance anyways. So I focused on theta GPU for DDP since it is a little bit more effective on GPU. Performance is on par with TensorFlow. On theta, it should work, but performance will be much worse than TensorFlow.
See some people getting some jobs up on both systems. Feel free to let us know how things are going in the distributed deep learning channel. Feel free to say, I ran this on that system and it worked. That would also be helpful. So at this time, you should feel free to run the DDP examples, run the Horovod examples, use the submission scripts that are available. Hey, perfect. There's
Cool.
a
I put up a poll to see if anybody is able to run it successfully.
still queuing. Okay, let's see. There are still plenty of nodes available on Theta. So if you are waiting for Theta GPU,
We have 14 nodes idle on Theta GPU.
yeah, and
And some things are queued. I see the problem. User A Bandic has asked for 18 nodes for an hour, and that's holding everybody up. So if you could,
no, that wasn't submitted to the proper queue. That's why that should be fine because that'll sit there on the queue until our reservation is over. The people who are queued are because they submitted to the full node queue and not the training queue.
you should be able
So
to directly modify. Let me post the command.
yeah, so just do a queue alter. Is that helping people? Let's see, I still see Jay Navarro is still on the full node queue, could switch. S. Hudson and Filippo, you guys are sitting on the full node queue and you need to be using the training queue. So -q training. Corey posted the alter command. It could be that alter doesn't actually let you swap queues because of scoring issues. So you might have to actually delete. Oh,
Ray suggests Q move.
hey, there you go. Does that work for people? Let's see. The other option is that you do a QDEL, so DEL with job ID, you delete the job and then you resubmit it. I think we had, let's see. And Jay Navarro, please make sure you're only using one node on Theta GPU. If you want to use multi-nodes, please go feel free on Theta proper. There are still plenty of nodes available there. If you're on Theta with the CANLs, you should definitely use multiple nodes. I see most people are using 4. So if you're waiting for jobs, I think everybody's on the right place now, except for Huiho. Huiho, you have a job on the full node.
Sorry, I will remove that. Delete that.
Well, I wasn't sure if if that was a mistake or not. Yeah, good. I see some jobs on Theta. I see jobs coming and going. That's good. Jafu, you're probably trying to run QSub in your interactive session because I see you have an interactive session that's been running for about 54 minutes. You're the longest running job at the moment. So you can't run QSub while you're on the actual worker node. So you would have to exit and then try QSub. And maybe when you post your questions and issues, it might be helpful to know, are you inside an interactive node? Or, if you just post the host that you're on, that would be helpful for us. Huiho just posted a comment related to the archive issues that we had been seeing, which are related to the data sets being available from the network. Thanks for everyone being patient. Thanks to all the people answering questions. I even see attendees answering other people's questions, which is great. Thank you so much. We're trying to avoid the usual case where we just talk at you and lecture at you and hope that it helps, and actually get people running code on the systems, and giving you an avenue to ask questions. Still see people submitting jobs. Good.
I see 3 people have successfully run DDP, which is awesome. So at least some success. If anyone who hasn't had a success, it's crashed or something, please just send a message on Slack and we'll try to help you.
Mhm.
Okay, I see.
The runners
Uh,
aren't intended for
yes.
QSub, right? The
Yes,
runners.
you only launch QSub on the scripts that have QSub in their name. And those scripts call the runners in that, I'm still sharing my screen, let me highlight it. Line 24 of the QSub script, it's gonna launch MPI run for Singularity, and Singularity will be the one calling the runner scripts. If you're doing an interactive node and you launch a Singularity session, you can run the runner script directly then. Otherwise, if you're using QSub, you don't run the runner script directly, you run the QSub script with QSub. Sorry, it's a little convoluted. The reason is because we set up this virtual environment in the container, we have to actually put that into a different script. David, I see your error message. Running MPI directly is not supported. Use AppRun instead. This is a difference between Theta GPU and Theta KNL. On KNL, which is just the original Theta, it's AppRun. You can't run MPI directly. So it sounds like, based on this message, you're trying to run on Theta, but running a script using MPI run, which is probably targeted for Theta GPU.
Let me unmute myself. It's so much easier to just talk.
Absolutely.
I have like a direct confusion on what's happening with Theta versus Theta GPU. All I did was I took the QSub scripts and then just changed the directory, and then of course put in the training stuff. So what am I missing for the run on the GPU versus the non-GPU?
I'll give you the history. So Theta was here first, came a few years ago, and Theta GPU was an add-on this year, targeting mostly COVID research, but we're using it for this workshop. So it's not integrated fully yet, so you can't launch jobs as easily directly from the Theta login node. So when you do SSH, your username at theta.login.alcf.gov, it dumps you onto the Theta login nodes, and from there you SSH onto Theta GPU. So it has a different service node.
I got you.
Yeah.
So I'm missing the SSH part of the whole thing.
I think so.
And where was that in the instructions?
I think it's on one of the README pages, and I think I pinned it, or someone else pinned it on the chat. I can scroll up and copy and paste it again. Maybe Ray, I don't know. Maybe we should have a a read-only channel with
So
some of these gotchas.
there is in fact a read-only channel. In announcements, I pinned this info. So just take a quick
Okay.
look there and
Awesome.
see if anything is out of date or needs clarifying. In the machine reservations section, I put Theta GPU from the Theta login to that from
Okay,
the
so
host.
all right, so I'm at the login, then the normal. Oh, I see. From Theta login. I got you. That's what I'm missing.
Right, so you need to do 2 hops.
I see. My bad. Sorry, guys.
No worries. Thanks for asking. It looks like there's a bunch of idle nodes, so you should be able to hop on and run it right away.
That's perfect. That's exactly what I'm going to try. Thanks again.
Mhm. Are there more questions for either me or Huiho, or in general? You can ask about really anything we've talked about so far.
Yeah, and we'll break for lunch here in about 15 minutes. We have the reservation through the lunch hour, so people should feel free to use that if they like. And then we'll come back at 1 o'clock Central.
If you want to try bigger jobs during the lunch hour, say 4 nodes on Theta GPU or something, and you keep the time short, 10 minutes or so, I think that would be fine, since we're not all trying to do it interactively then.
I just have a suggestion to folks when we do break is that if you can leave your Zoom session connected, it will probably be easier that we won't have to readmit you after lunch.
Since there weren't hot questions, I'm going to talk a little bit about what you see in the output, since I think it could be useful. So I ran this a bunch of times to measure scaling, and I was dumping my output into these files, 1 node, 1 GPUs, 1 node, 4 GPUs, 8 GPUs, all the way up to 4 nodes, 8 GPUs for both CIFR10 and MNIST. And one of the ways you can tell that it's working correctly in the container is if you look at the output. I'll just look here. This header stuff comes from the container itself. So when you launch this container, NVIDIA likes to dump all this sort of garbage at you. And then here's some of my echoes from the runner script, and then you'll start to see the train epoch information come out. And 50,000, 0 out of 50,000 samples is telling you how far along it's in the epoch per node. So with 1 GPU on 1 node, we should see all 50,000. And it progresses for a while. And eventually at the very end, after 32 epochs, when we get there, it shows you what your average loss in accuracy was for the training set and for the test set. So there was some overtraining here. I'm not too worried about that since this is CIFR10 and we expect with this model to get this. And I was really focused on just implementation and performance. But it also gives you the average time per epoch over the last 5 epochs. And then if I look at the one that's 4 nodes, 8 GPUs, I get this header information 32 more times, which is super annoying. But then when it actually starts running the script, each epoch only has 1,563 samples per step because it's divided the total data set across nodes. So it's only running 3 steps instead of however many it was before, probably more like 60 to 90. And you come down to the end and it shows a much reduced time. And at least this time there was no overtraining particularly, though the test average accuracy was much worse. But this is how you can tell that you're actually distributing properly. The data size is smaller, the time per epoch is faster. And one thing I think we haven't mentioned is if you're on an interactive node, there's a command you can run. If you don't know it, NVIDIA SMI. It will error for me because I'm on the service node. But if you're on a compute node on Theta, this will work, and it will give you a printout of every GPU on that system. You'll see all 800s, as well as what their memory usage is at the time, what processes are running on them at the time. So if you're unsure if you're running on the GPU, use this on a different terminal, and you'll be able to tell. And if you have an interactive node, say you have Theta GPU 01, and you've launched that with an interactive node, you can always open a new shell, re-SSH to this point, and then do SSH here again. And it'll allow you to access the terminal if you want to run something like this on the side and see what the usage is.
We have a lot of threads going, so if you feel like your thread has gone idle, let us know. And you can also, in Slack, you can use the @ symbol and then type one of our names, and it'll alert us to come look at that thread. I see Midu, at least the username MIDU, you should, or that's Ming. I mean, you need to update your queue name from full node to training. Otherwise, you'll just sit in the queue. And same for user ZQIAO. Your queue name instead of full node should be training. I think we had full node in our instructions, but it should be training because we set up a training queue for today and the next days. So always make sure when you do your queue sub, you're submitting to the training queue under the SDL workshop project. And you can see those if you do QStat, you can see what everybody else is submitting to who's running and those of you who are queued. And somebody should say whether or not the queue move command, did that actually work in getting people moved from one to the other?
I see a report that QMove didn't work. If QMove fails, just delete your job and relaunch it with the right queue. Since these are short jobs so far, I don't think there's any downside to doing it that way.
Let's see. Jifu, can you delete your job that you submitted to the full node? I see you fixed it. You know, you got or you have another. I see. Yep. You have a 2-node job that you submitted to the wrong queue, Jifu, on Theta GPU.
Yes, this is I deleted. So should I use the option? How could I change the queue? Like just set a queue to training?
So we found that the QMove and QAlter didn't work. So you have to delete the job and then resubmit it.
I deleted.
Okay, perfect.
Then how could I resubmit it? Like
Hey,
just
I'll
use
help
exactly
you.
the same.
Just make
I'm gonna-
sure that
Let
when
me
you.
look. Do you see my screen?
Okay, there you go. Yeah.
This part right here, dash Q, is telling you Cobalt what queue to use. So it needs to say dash Q training.
Okay. Thank
Does
you.
that help? Yeah.
I'll give it a try.
Good luck. Thanks, Ray, for pinning that message on announcements. For those of you who had questions about Q, stat, theta, Cooley, etc., he posted some slides from @PESC this past summer with an overview of the systems. So it's a different workshop, but the same systems. It could be a great reference if you have, if you want a sort of a visual list of all the QStat commands, how to check your jobs, etc. So that's on the announcements channel. Stephen, who just asked what --nv does. Singularity is more general than just GPU software, but the GPU runtimes needed to run an NVIDIA CUDA compatible code aren't activated by default. So you pass this --nv to Singularity, and it tells you that, or it tells Singularity that you're going to need access to NVIDIA GPUs, and it better load the GPU runtimes too. So if you try without that, your jobs won't run on the GPU.
I think some of the scripts are assuming that you would run the Q sub from the, I think the Horavat scripts assume that you're running inside the Horavat directory, not down in the submission theta or submissions theta GPU directory. Is that right? Because of the results folder being there? Or does that get created if it doesn't exist? Because if somebody goes down into the submissions directory and then runs their Q sub, the script tries to run, and if the results directory doesn't exist, it may fail and say, okay, I don't know where that folder is. Okay, I'm gonna call break. And attendees, just a reminder, please keep your Zoom up, muted if you can. Otherwise, you have to rejoin via the waiting room when you come back. The submission is open in lunch, so feel free to use the system. I would ask not, obviously don't, if you do a QStat on theta GPU, which I think is going to be the congested one, and you see that a bunch of people are queued and you've been occupying multiple nodes or a node for a very long time. I see a few people on theta GPU that have now had their node for over an hour. I would ask you to release those if you notice people have queued jobs. If there are no queued jobs, don't worry about it, use the node. But let's be respectful of everyone and be kind to one another, which is our, I think, is officially the first policy at ALCF. If you look at our policy page. I'm not kidding. Otherwise, enjoy lunch, and we will reconvene at 1 o'clock with a discussion of data pipelines. We can, I'll be running that session. I don't expect it will take 2 hours. So we can keep working on distributed deep learning if we want to, if there are still questions and issues. Thanks everybody from data science team who have been fielding issues on Slack. Please come back at 2 and help us. And I'll see you guys, or not at 2, at 1. Sorry, at 1. Okay.